Welcome to Cut the Crop, keeping you in the know about everything you grow. Researchers, growers and other interesting folk delivering insights and information on topics ranging from agronomy to profitability. Brought to you by the Foundation for Arable Research.
Hello and welcome. My name's Alison Stewart and I'm your host of Cut the Crop for this week. And today we're very lucky. We've got a guest from the UK, Clive Blacker. Hello, Clive. Welcome.
Good morning. How are you doing?
I'm good. Excellent. And so you're a precision ag expert as well as a farmer from the UK.
Yeah, that's correct. I get a bit embarrassed by the title, but I wouldn't class myself as an expert, but just an enthusiast, I think.
Okay. So, look, just start telling us a little bit about yourself before we start going into talking about some of the precision ag, sort of stuff that you've been involved in.
Yeah, so my background is I come from a family farm in the Vale of York in North Yorkshire, UK. I started getting into precision ag and GPS technology back in very early days of 1998 and 1999. It's when we first started yield mapping and looking at remote sensing as opportunities for agriculture to manage variability. And we also then got involved with Yara at that time with their N sensor because we were really struggling to get satellite remote sense data. Where we farm in the Vale of York, it's quite a flat vale, but we get small variabilities in height that are related to old glacial deposits. So we can go from quite heavy clay soils to quite light sandy soils within the space of a few meters in a field. And it never made sense to me on the farm at home to treat them all the same because the requirements were different. So we started looking at technology in which we could measure those differences and try and understand them, put numbers to them, and then manage them differently. And that's really where my lessons started. I'm not educated or taught in anything I've done other than self-taught.
So what crops are you growing? What's your rotation?
When we first started with all the variable rate stuff, we had cereals and we had cereals, so combinable crops. We were farmers and contractors, so we were contracting for sugar beet. We had a local sugar beet factory at York, but that closed down in the late 2000s. And then we also grew potatoes, but only on a small scale. So as we've evolved and mechanised over time, we've got rid of some of the sugar beet as the factory closed. The potatoes was only 25 hectares at the most. And it was just expensive to keep in that game. So we just specialise now in just combinable crops and trying to do a better job of combinable cropping.
So how did you get into the precision ag? I mean, did you go to conferences or workshops, or did, sort of ag tech companies walk up the drive and sort of show you things? Like how did you first?
Yeah, so I got into it just through interest. I mean, the first time I saw something with GPS and precision farming was probably a BASF open day. Down in Holderness, when a farmer there had got a prototype Massey Ferguson combine with their Field Star on. And my dad thought he was barking mad because he'd got this new satellite receiver on there that was really expensive, and he could only operate the combine at certain times of the day when the satellites were passing at that time, so he could get positions, and he was restricting some of his combining through that. And Dad just thought that was crackers, but I saw that in probably the late 80s, and I was really intrigued by it. And it wasn't really mainstream. We got the first class yield mapping systems in the UK in 1998, 99. We started working with the N sensor at the same time, and it was us really knocking on their doors and demanding the technology, as opposed to people coming up the drive and trying to sell it to us, because it just didn't exist, and people certainly didn't understand how to use it or visualize any data.
Yeah.
And it's still a bit the same.
So let's talk about the N sensor stuff, because that's obviously what you've been over talking to various people here about it. So maybe just start off with the history of the N sensor technology, because from listening to you to today, there's obviously been a lot of evolution of that technology over time.
That's right. So the reason we started working with it was because we just were let down so regularly with satellite remote sensing. And I don't think it's too different today. If we're using optical systems from space, they've got to be able to see what you want to manage. And apparently you call New Zealand the island of the long white cloud, you'll understand what it's like to have cloud cover. And the UK is no different. So if you're wanting imagery about a crop when the crop's growing and you can't see it, then the technology is sort of worthless. And Yara had come up with the concept of building a sort of satellite, but sticking it on top of the tractor cab. So that you didn't compromise that timeliness. And timeliness, I'm told by my wife, is next to godliness, and I'm nowhere near that. And if we want to make the right interventions at the right time, we've got to do things in the right manner. And the sensor just made perfect sense to me. So it's a satellite on top of my tractor cab. I could scan the crop every time I went through it. And we're quite invasive in how we manage our crops. We might go through a crop a week 14 times with different interventions in the UK through fertiliser, agrochemicals, growth regulators, fungicides. And it just made sense that if I could get a sensor that was there every time I wanted to go through, I could capture information, I could review it, and then make a decision on whether I should then influence another decision with the management of the growing of that crop. And I could do it before harvest. It wasn't passive; it was active to that crop in that season.
So just talk through like the rationale for why you want to, monitor and record, nitrogen content in your crop, and how you've used that to inform your decisions about variable rate application.
That's right. So I mean, there's a lot of variability in our crops, I say, because of soil textures. And they don't always behave the same in every year. There isn't a blueprint to farming, and I think it's getting harder now than it's ever been. With we're certainly in a climate change, whether you believe in climate change or not. We're certainly having to manage crops in a different way and deal with different climate management implications. So having technology that you can be agnostic about when you want to use it to go and do that. Why nitrogen? Well, from a management perspective, it has always been my single biggest input cost. In terms of growing a cost, I spend more on nitrogen than anything else. As time's gone on, it's become more political. And we didn't get involved with nitrogen from a perspective, it's an economic perspective we started with, but it's becoming more critical from a watercourse perspective, from a leaching and contamination perspective, but now also from a greenhouse gas perspective as well. And, work that the AHDB has done in the UK, that's our Agricultural and Horticultural Development Board. They would suggest that 83% of a farmer's greenhouse gas emissions are coming from the use of nitrogen. 50% of that being from the production, 50% for the way we then use it. So if we're going to be serious about how we meet regulation around climate change and meet net zero opportunities and goals, then we've really got to understand how we're going to manage nitrogen and get the best out of it.
Yeah. So talk through, what are the benefits that you've seen on farm from using this technology?
So the benefits we see are improved crop performance. So we get a yield advantage. So where we did trials in the early days looking at the use of variable rate technology using the same rate and information that I would apply as a flat rate as a farmer, we were seeing yield responses from anywhere between 3 and 15%. It wasn't always 15%. They were in the extreme conditions where perhaps we'd got manures or other interventions that we were using that we all struggle to manage because we never know when nutrients will become available. So that in its own right was significant. We've used it with growth regulation, and we've used it trying to then manipulate the canopy to have more of a canopy management approach as we grow that crop. So the benefits we sort of see are improvements in combining. Makes the crop more even. We don't get the lodging problems. So it's cheaper to get it into the shed. We don't have as much drying costs at times. It certainly helps with growth regulation, keeping that crop stood. We get beneficial improvement in yield, and we've proven that in some of the replicated trial work that we've done. So it's a no-brainer to us, really, and it allows us to measure that crop every season and benchmark our production.
And one of the things you mentioned earlier when we were talking was around being able to reduce your nitrogen.
Absolutely, yeah. So the work we've been doing, I've been doing a lot of work recently, as we're sort of changing the way we think about farming and looking at more integrated management, more regenerative type approaches by including cover crops into our cropping rotations. We're needing to understand better what the soil's doing with those cover crops, how it's handling it, how it's releasing nitrogen with mineralization. So the whole approach of trying to manage nitrogen better is becoming more challenging because we're getting different things that are trying to demand that nitrogen or release it at different times that we then have to manage as well. So having a tool that allows us to monitor the crop, to benchmark its performance so we can make informed decisions is really, really important.
So, I mean, talking money, return on investment, it's not cheap, these pieces of equipment that you're putting onto the top of your tractor. So Are you sort of really comfortable that you are getting a good return on that investment?
Yeah, we looked at that significantly over the years, and it really does vary. So if you've got low nitrogen prices and low grain prices, it's a lot harder to make the technology pay. But you look at the extremes we've had in just the last few years, particularly with some of the inflation we've had because of the war in the Ukraine. Fertilizer prices, they tripled, if not quadrupled. So suddenly the economics look ridiculous, and you need very, very little savings in fertilizer, very little improvement in yield in those circumstances to make it pay. But typically in the UK, we would say that if you've got 100 to maybe 120 hectares of cereals or oilseeds, you'll make the end sensor will pay for itself without any problem. Yeah. You get more than that, the figures start getting silly.
And so, I mean, you've obviously been using the technology for a reasonably long period of time. You're one of the early adopters. Do you find that you are getting like other growers in your region seeing what you're doing and then wanting to sort of follow suit?
Absolutely. And as we get more political pressure on nitrogen, it's becoming more common spread to the point, government are taking the technology seriously. So government will support farmers in some respects or put incentives in place to help farmers lower that risk of adoption of the technology, because they recognise it has an environmental impact and that's in a positive, and it's going to help farmers improve their yields and profitability and quality of food.
So obviously you're over in New Zealand, but you've been over in Australia as well. So what's the purpose of the 2 weeks that you've come down to this end of the world?
Oh, well, so in Australia, we were looking at doing some work with a UK-funded government initiative, looking at doing some joint research with Australian researchers around Earth observation. So trying to get better use of some of the newer satellite technologies and looking at how we can integrate the remote sensing into crop models, so we can make crop models more intuitive and timely to the season that they're actually growing with. So rather than the crop model being used to predict what might happen, we can do that, but with live interventions of what's happening based on some of the feedback and opportunities now with newer satellites that we really don't understand as well as we could do with radar, for example, that can penetrate clouds, means that we can get information about crops even on cloudy days, which opens up the windows of opportunity. So that's very much a high-level research opportunity to try and understand that technology better and how agriculture can use it. And the reason I'm over here in New Zealand is really to support the growers here that are looking at adopting the end sensor technology through Yarra and Drummond and Etheridge.
So what were the big challenges that you had to overcome in order to get the technology to work on your farm? And I mean, are there good lessons that you can pass on to New Zealand growers that want to do the same?
Yeah, so in the early days, it was very complicated, and one of the things I think Yarra have been very smart about is how they've set the system up so that they've hidden all the science, essentially. It's not complicated to use. They've made it a lot easier to use than it was in the early days. They've made the system very simple to fit and move around to different vehicles. So it's quite intuitive and it's quite infectious. Once you start using it and using the data, you start seeing things about your crop and you start asking yourself different questions and challenging your own thinking. And that in its own right has big benefits. The ability today to have communications with different equipment, that was one of the real challenges in the early days, was compatibility. Yeah. A lot of that issue has disappeared. That it's not without its challenges. There's still control systems that can cause problems, but the opportunity to make the systems work and integrate seamlessly are there. And it makes it easy to use and adopt. And as more people are using it, there's a bigger knowledge base that supports each other.
So, I mean, obviously, in order to make this technology work, you have to have a lot of data around, how you've calibrated the equipment for certain crops. And a lot of that has obviously been done overseas. Is that calibrated data going to be relevant in a New Zealand environment?
Yeah, from what we've seen so far, it translates nicely. What I expect to see, some of the varieties that you grow here are the same that I would grow in the UK. So last year we were using the N sensor on X-Days. We grow X-Days back in the UK. What the N sensor is telling me with the data I'm seeing is that it's exactly the same. The climates may be slightly different. The way your mineralization might occur at different times. But what the sensor does and how the sensor measures that, it's been done intelligently enough to do that. Now, we have to trust it. We have to trust the sensor technology. One of the criticisms that farmers often have is that, well, why would I want to use a sensor that's been developed by a fertilizer company? Surely it's a system that's going to sell me more fertilizer. Yeah. But one of the things I would always say to the farmers is, well, it's been developed by some researchers who want to improve nitrogen use and make sure that nitrogen is a secure input that we can continue to use. And that's really important, because if government or environmentalists get their way, they'd probably stop us using it. And we've all got to eat something. Nitrogen is fundamental to making sure that we all have some food on our plates.
Yeah. So the rationale is, I mean, if you're a fertilizer company, in order to secure your future business, you want to make sure that farmers are only using that input when they absolutely have to.
Absolutely. And profitably and responsibly.
Yeah. Excellent. So maybe if we just open it up a little bit and talk about some of the other sort of precision ag tech that you're familiar with, and also talk about your perceptions of New Zealand versus, what's happening in the UK. Are we adopting technology in the same way? Are we ahead or behind what you see the farmers in the UK are?
Yes, in terms of technology, well, technology's changed a lot over the years. I could do a whole podcast on grievances with precision ag technology and where I think it might go. And I do have some challenges with where we're going with mechanization. One data perspective I often use is that I get 60% less yield data today from my combine harvester than I do when I first started yield mapping.
Okay.
And people say, well, that's really weird. Why do you say that? I said, well, efficiency. I've got to cut a bar that's twice as wide. It's collecting half the information because I've only got one data point. So technology and progression isn't always a positive if we're wanting to apply precision. And I could say I could do a whole podcast on that. In terms of technology update and how technology is used internationally, I think we're all very much similar. New Zealand's very similar to the UK in that you use a very much a crop model. You're using, in your models are still very much around active plant management, using the plants and feeding back within the season. It's not prescriptive, it's responsive and prescriptive at the same time. And I think the way you're using the technology here is very, very similar. The discussions I've had with the farmers have been around variable seed rates, variable growth regulation. They're all common in the UK, the same discussions. So I don't see any big changes. Where I do see some differences is perhaps around how you're integrating some overwinter cropping better than the UK. There's a lot of kale, there's a lot of livestock in the rotation. Yeah, and right. I think that's a real positive. And I think the UK could probably learn a huge amount from that management and how to manage that.
Excellent. I guess I'm quite interested to know where you guys sit with respect to sort of, carbon net zero targets and whether the technology that's available is facilitating growers being able to meet those big environmental targets.
I think we're only scratching the surface of that at the minute. I'm not sure I think we really understand where we need to be. One of the big problems with that is we don't have the data sets that we need to make the measurements or perhaps the methods of accounting accurate. And I think one of the weaknesses that certainly net zero and carbon has is that there's a model based on a model somewhere that's no doubt based on some bullshit in the middle. There's been some work done by the National Farmers Union in the UK that they've identified over 63 different farming carbon calculators that they could potentially use on the farm. So I think there's a lot of nonsense. And I think we need to be very careful as an industry. If we're going to make interventions for carbon and understand our net zero position, we need some leadership from industry or government to actually put some standards in place that we can actually measure ourselves by and then work out how we can use those interventions or measurements to our benefit or how to manage around them.
Yeah. And we're experiencing the same issues, with our greenhouse gas calculators. There's about 9 or 12 of them out there. And depending on which one you use, you're getting completely different emissions profiles. And so you could game the system if you really wanted to. Yeah. And so we're just trying to work out how can you come up with calculators that cover the same basic criteria. Right. And that they can be transferable for a dairy system versus an arable system or whatever. So, it's sort of, I think we're all in the same boat. And I think one of the challenges we have in New Zealand is because we're so far away from, sort of particularly Europe and North America, we don't necessarily see the drivers, the global drivers, and because we're a domestic-focused market, we don't necessarily pick up on how things are happening overseas and how that's going to play out. It's a whole right to farm type of thing and the right to sell your product.
Absolutely. And, we're moving into changing times with that. It's going to become very much retailer-led in some respects, with retailer-expected interventions that they will only produce food or purchase food produced under certain environmental criteria. And I think they'll very much drive the market. I am involved in a number of trials in the UK, specifically, around nitrogen use efficiency, and we're trying to develop a better framework for improving nitrogen efficiency in arable crops, and we've got retailers involved in that conversation. Mm-hmm. And the whole challenge is very much around the net zero. How do we meet net zero challenges? What are the data sources we need, and how can we gather that data effectively without burdening ourselves with more blooming paperwork and systems?
So is there any other technology out there that, that you're really excited about? You think that, oh gosh, in another couple of years, I'll be keen to pick up on that?
I see things in a very blinkered perspective. I've been very fortunate to get involved in all sorts of different things. And where will those technologies go? So definitely sensing and soil sensors are going to be something that will, I can think in the next 5 years, influence the way we farm. We'll have a prototype sensor next year that'll do soil moisture, soil nitrogen, and soil temperature. And I'm really intrigued to see what that will be able to tell us around when we're going to get mineralization and help us understand our nitrogen targeting better. I've done work. I've been lucky enough to be involved in some trials looking at how we can adopt the Mars rover in agriculture. So taking the sensor technology packs that they've stuck on the rover that they've sent to Mars, in Stevenage in the UK, where they did development of that, we had some work with Airbus, who were behind the development of the rover itself, to see, well, what technologies on there that we could deploy for example, for soil measurement. And we've been looking at how we could build 3D soil measurement systems with some of the laser-induced breakdown spectroscopy, for example, that's on that technology that will give us a full nutrient profile breakdown and allow us to map soils in 3D. So that sort of technology exists. There's a lot of work needs to go on to do that. But the opportunities that offers from a measurement perspective and a reduction in lab costs is quite significant. You combine that with the opportunity robotics provides, we'll have some really high resolution mapping opportunities.
Yeah. So is there any evidence out there in the UK and European markets that you get a financial recognition for all of these amazing sort of efficient ways of producing food? Or is it now just you need to be showing that you're doing that in order for me to buy your product? Is there a premium out there for precision ag?
Not as yet, but I think that's starting to change. I think certainly from a net zero perspective, that's certainly something that the food retailers are certainly looking at. So one way, if we take nitrogen as an example, there are some retailers now saying to their farmers, you cannot grow a crop of this or supply this particular product to us unless you've used green ammonia produced nitrogen. They recognise that there's a cost disadvantage to the farmer for doing that, so are providing a premium for the purchase of that for the farmer so that he can purchase that nitrogen.
Okay.
So things are starting to shift in the right way. Whether whose pockets it's going in, I'm not sure. I'm not convinced it's always the farmers, but at least we're making steps.
The farmers, we know that. We're price takers.
That's right. Yeah. But we're still making steps in the right way, and the frameworks are being put into place to enable that to happen. And there's some leadership starting to happen in those sort of areas.
Thank you very much for some really nice insights, and safe travels back to the UK.
Thank you very much for having me, and it's been a real pleasure to be here.
Okay, and thank you very much, listeners. Have a great day on the farm.
Thanks for tuning in to Cut the Crop, presented to you by FAR. If you'd like to know more about any of the topics discussed or have any suggestions for future topics, go to www.cutthecrop.co.nz.